Good morning or good afternoon to everyone, depending on where you're joining us from. My name is Christina Bowling, and I'm the Chief Administrative Officer for DSC Dredge, and I will be helping to moderate today's event. Thank you for joining us for today's webinar, DSC VISION, Revolutionizing Dredge Operations. DSC VISION is an exciting new collaborative technology that we're pleased to share with you all. Before I introduce our three speakers, I'd like to just cover a few housekeeping topics for everyone. Today's webinar is being recorded, and we will be able to share a link with you after the event is complete. We welcome you to revisit the content and share it with your colleagues as you see fit. We also invite your comments and questions. Please look at the Q&A and chat boxes on your screen. If you think of a question for the speakers at any point, just type it in there, and depending on time, I will either pose it to our speakers at the end of the event, or we'll provide direct follow-up with you after today's event. Since there are so many of us joining today's call, we have automatically muted everybody. We ask that everyone remains muted throughout the call and only submit questions through the Q&A chat feature. Today's presenters include three industry leaders: Bill Wetta from DSC Dredge, Ted Germann from Teledyne Marine, and Jonathan White from Trimble. At this time, I'm going to hand the floor over to our host, Bill Wetta, DSC Dredge's Senior Vice President of Product Development and Chief Technology Officer, who is going to start today's presentation. Bill, it's all yours.
Thank you, Christina. Good morning to all our North American attendees, and good afternoon to our European and African viewers. And thank you for joining this presentation on DSC VISION, which is a revolutionary product that aims to eliminate dredging in the blind. For those of you who don't know about DSC is a family-owned business, and we operate primarily headquartered in the state of Louisiana in the United States. The founder of DSC, my father, is shown on the picture on the left. He was a watch engineer back at Standard Dredging on that photo. In the early 1960s, he became the first dredge engineer for a large company called T.L. James Company. And they created a large dredging fleet, and he was the one that actually managed and maintained that fleet. The two dredges you see on the screen, the Bill James and the Tom James, are two of the dredges that my father designed and actually worked with the manufacturer of. The Bill James today is now known as the Dredge Texas with Great Lakes, and the Tom James is now known as the Captain Frank with Weeks Marine. In 1971, my dad left T.L. James and went into business for himself. He created a company called Kenner Marine and Machinery, and that company manufactured smaller equipment and refurbished larger dredges and boats. My brother and I had the opportunity to work summers for my father. My brother Bob is our CEO, and in the summer of 1980, I designed the first portable dredge manufactured by Kenner Marine at the time, the Billy Goat 1 dredge, that's now shown on the screen. That dredge went on to be copied, and about 60 of those machines were built. And that machine later on became our Shark dredge, and we've built hundreds of those machines since. In 1989, Dredging Supply Company was formed basically to provide capital so that the Kenner Marine line of dredges could continue to grow. So we brought in some private investors, and back in 1994, DSC was again purchased solely by the family. Next slide, please. In 2010, DSC Dredge LLC was formed basically as a parent company for the Dredging Supply Company and some of the other acquisitions that we had purchased. Most importantly, W&S Dredge and Best Equipment Technologies. As you can see on the global image on the right, DSC is a global leader in dredge manufacturing, and we're represented in almost 50 countries and represented in almost all of the 50 states. Our products range from 8-inch dredges through 36-inch dredges. That would be 200 millimeter to 900 millimeter pipeline size that operate from depths typically from 18 feet to 200 feet, or 5.5 meters to 61 meters below the surface. DSC's reputation is built on an unwavering commitment to the customer and dedication to delivering a superior product and outstanding service after the sale. And we've been recognized for that, as you can see in the graphic to the lower right, the excellence over the years. We've been awarded presentations and awards by government industries, community industries, and trade associations alike. DSC, as well as being a dredge manufacturer, is also an engineering company, and most everything that we do, and one of the most important things we do, is research and development. And what we learn from that research and development, we pass on to customers and our competitors alike in classes that we teach at Texas A&M University in the Center of Dredging Studies, presentations we do for the Western Dredging Association, the World Dredging Association, Ag 1 Academy, ConExpo Academy, our own dredgecation classes, and seminars like this. Next slide, please. DSC's future. DSC's future is taking shape now by leveraging the creative thought and R&D over the past few years. The image that you see on the left, the SHARKUDA, is our newest revolutionary dredge that was introduced last year. This patented dredge continuously moves forward without the use of anchors and makes a much wider swing than is capable of a swinging ladder dredge. The glider mechanism that allows the spuds to move is patented as well, and that's being retrofitted now onto DSC's more conventional CSD dredges and swinging ladder dredges. And we'll see more of how the SHARKUDA and the spud gliders operate as we move forward in this presentation. The caption on the lower right is our DSC Dredge caption. Dredge RX product. Dredge RX was released about 3 years ago, and Dredge RX is a remote connectivity feature that's built into all of the equipment that we manufacture today. So it allows management to remotely view the dredge and get historical information off the dredge. It also provides DSC a window into how the machine is performing and what types of services are taking place on it. A mature version of that is being released this year, and that version allows customers to customize the sites they'd like to see, customize emails on alarms. It also, with the use of some of the AI products, artificial intelligence, that's now on DSC dredges, it allows our product support group to get reports every morning on anomalies taking place on the dredge and things that may be able to be done to make the machine improve. We've released this year at our ConExpo show the DSC Dredge Master Suite app for the iOS. That's a free download on the Apple site, Google soon to come. And that provides benchmarking and real-time connectivity to all of our dredges that have Dredge RX. Dredge RX is also available on any type of dredge, so it doesn't have to be a DSC product. This app also has benchmarking tools, which will benchmark how the dredge is operating compared to other machines, and some handy tools for operators that are in the field. The long-term goal of DSC in the future is to provide dredges that are autonomous or semi-autonomous, meaning the dredge is aware and can work by itself or with limited interaction by the user. The real-time sonar and guidance piece that's shown is really the last step in putting that all together. Before I go on and talk about how all of this falls into the DSC Vision package, I want to let you meet some of the team that made this an affordable and available product now. So I'm going to turn this over to somebody who's become a good friend of mine in the process of doing this. This is Ted Germann. He's the Vice President of Business and New Markets with Teledyne Marine.
Thank you very much, Bill. And that was an excellent introduction to your company. And I think as we move through our talk today, you'll see why all of these companies have come together. Next slide, please. I know we have many people around the world listening to this, and for the first time, some of you might be being introduced to Teledyne Technologies. And just for your benefit, it's important to understand that Teledyne is one of the most prolific scientific companies in the world. We provide and share across Teledyne mission-critical applications in all of our markets, ranging everywhere from defense to marine. Next slide, please. I think a theme that will play itself out throughout this presentation is that from space to the bottom of the ocean, We are experts and world-renowned in imaging. As you look at the slide on your screen, you will see sensors that we have on the Mars rover, used across multiple markets, including healthcare and medical. And of course, the newest and hottest space that we're all taking part in and continuing to work with DSC on AI, or of course, machine visioning. Next slide, please. Now, as we work through Teledyne technologies, it's very important for you to understand the strategy used to bring in our marine division to help DSC bring DSC Vision to life. Again, we are experts in imaging from space to the bottom of the ocean across multiple markets, from our energy or oil and gas space to water resources and civil engineering, and of course, as I mentioned, defense and hydrographic navigation. And the navigation piece that you see there on the right, that's an image from a multi-beam sonar, and that is where we started to, again, leverage our technologies into a new space, which I'll build on now. Next slide, please. As you can see, I mentioned earlier, we work our technologies across the company. Most leading space missions rely on Teledyne detectors. As you can see on the left, we have the James Webb Space Telescope, the famous Hubble Space Telescope. As we work across the scene there, you see us using our LiDAR technologies to our shallow water multi-beams, as you see a survey being done second to the right, all the way to our deep multi-beam sonar systems that can map all the way to the bottom of the ocean. All of these technologies, again, from space to the bottom of the ocean, we use and leverage into key solutions that we develop for our strategic partners. Next slide, please. This is a very important slide, and one at Teledyne that we are quite proud of. The picture that you see on the middle left is Teledyne Technologies, and the picture that you see in the middle on the right is our Daytona Beach headquarters in Florida for Teledyne Marine. We have developments of new technologies done across these major government agencies that we bring to our commercial markets, whether it's DARPA or NASA, NUIC, NOAA, Woods Hole. It is a very long, impressive list, and it's our ability to work strategically with these agencies to solve some of the world's toughest scientific problems that led to bringing DSC Dredge, Teledyne, and Trimble together. Next slide, please. The challenge that we had put forth to us was we'd like to take that great imagery provided in your hydrographic and survey space, generally used on a survey boat. Many of you on this call are familiar with pre- and post-construction surveys. How can we move that technology into a real-time visualization solution for the operators in heavy construction equipment, whether it be a wire crane, an excavator, or a dredge? Allow the individual inside that cab to see in real time, so when that survey boat comes back at the end of the day, end of the week, or a month later, no material is left behind and the job is done much more efficiently, and a better return on investment is achieved for the organization. Next slide, please. So with that, it's important to understand we have the pieces, but technology, I oftentimes say it's a race, it's a progression. How do you move adjacently for something you've done in one market into another market and make it so for the operator in this case, they have the same capabilities as a surveyor, but they get to see in real time, and in often cases, they're working off of a stationary platform. The challenge we had put forth to us was give the same advantage to the person in the cab that that surveyor in the boat has after the fact. And we've done that, and that's what we'll bring forth today. But it's also important to remember, you have to know, where are you? Where are you working? Where did we see that? Where was that material left behind? And that again is where Teledyne and Trimble Technologies have come together to provide excellent guidance and GPS locations for where work is being done anywhere in the world, and it can be seen real time anywhere in the world. And with that, I turn this over now to our friends at Trimble, Mr. Jonathan White.
Thank you, Ted, and thank you, Bill, for having us here today. Again, my name is Jonathan White. I'm a product manager for Trimble's Civil Engineering and Construction division, and my focus is in the marine business area. So next slide, please. For those of you who may not have heard of Trimble, we're a very large, publicly traded technology manufacturing company. We're similar to Teledyne in that we also have a diverse product portfolio with technology used across many industries and markets, but we pride ourselves in being a global leader in connecting the physical and digital worlds through our primary core business, which is geospatial and construction surveying, including machine control. Trimble technology is deployed on some of the largest construction projects around the globe. And over the last 30 years, we've built partnerships with an extensive range of OEM manufacturers who offer Trimble guidance and machine control on their own machines. Today, we can add DSC Dredge to that list. Next slide, please. So over the years, we've taken what we know about machine control and guidance in land construction and applied it to where dirt meets water for marine construction applications. Of course, that's why we're involved in this partnership you're learning about today. Other Trimble civil engineering and construction markets which may be relevant for this audience include our extensive range of site positioning and connectivity solutions, also paving, milling, and compaction, and drilling and piling solutions. Next slide. The Trimble technology integrated into the DSC VISION system provides precise position and heading and also measures motion of the ladder and attitude of the dredge. The sensor data is communicated back to DSC VISION, so the location of the cutter tool and the sonar soundings can be accurately measured and displayed within the DSC VISION user interface. The Trimble MPS 865 GNSS receiver paired with ruggedized marine-grade antennas provide that position and heading. By GNSS, I mean that the receiver makes use of multiple satellite constellations, not just the United States GPS satellite constellation. This means that you have more satellites in the sky, which helps to quickly and accurately triangulate your position on the ground, or in this case, on the water. Different levels of precision are available, from greater than a meter down to 1 to 2 centimeters of accuracy. The angle sensors we're using for this system come from our LoadRight group within Trimble, and they're built to work on machines in tough, harsh environments. The attitude sensor is typically installed inside the cabin along with the GNSS receiver. That attitude sensor gives us the pitch and the roll of the vessel. The latter sensor is enclosed in a heavy-duty stainless steel submersible enclosure rated for a depth of 20 meters. Now I'll turn it back over to Ted so we can learn how all of these hardware and software components work together to form DSC VISION. Thanks.
Excellent. Thank you, Jonathan. And with that, I'll conclude with my piece of this presentation. Next slide, please. What I'd like to do is, I told you that the challenge that was put forth was move vision from the surveyor to the operator so that we can work in real time. And I can't stress enough, Teledyne has all of the pieces. We share technology, and we also have multiple business units that we can work across with to solve problems. In this particular case, we used our Port Dredge Solutions group out of Rotterdam, our Keras software group out of Canada, and of course, our phenomenal imaging group out of Denmark. And we brought the pieces together to take our PDS software, which applies real-time data acquisition with an engine that can work across multiple marine construction applications. We paired that with Keras to process that data in real time. No longer takes days. Anywhere in the world, you can see what's going on as they work. But we also had to take in mind The operator is working in real time. The operator needs to see now. We needed to make the software go from multiple screens to just a few buttons for the operator to use so that they can see. And again, the challenge we had, the picture you see in the middle, is an actual aggregate mine, and where the arrows point indicates valuable material that was left behind. The objective was to provide a real-time visualization solution for the operator to reduce material loss and make the job much more efficient, easier, and safer for the person working in the cab. So with that being said, we now will get to the solution for you to see that we developed in conjunction with Trimble and DSC Dredge. Thank you.
Thanks, Ted. Next slide, please. When Ted mentioned that we came to them and presented Teledyne with a problem, the animation you see on the right is basically the problem that we presented them with. This is an animation of our new SHARKUDA dredge actually going through the paces and moving. And you can actually see what looks like anchor booms are really lines back to the ladder to help swing the ladder around. And as you'll see, the dredge is moving forward on 4 individual gliders or spud carriages. So this dredge has the capability from a control standpoint to really move forward, move backward, move up, move down, move left, move right on demand. Very, very controlled. The one piece that was missing, and in this image it looks great, but what is the material doing below the surface for real behind the dredge or in front of the dredge? How do we know what's there? And as you see with the dredge, it's going to make a move forward and it's going to swing back across the cut. What you'll see take place is very common in the dredging industry. So the dredge is moving across its cut now and moving to the starboard side. And as it moves away, you'll see that material is caving in behind the dredge. This happens on every dredge, whether it's in an aggregate market or a navigational channel or an environmental control job. What we wanted and what we tasked Trimble and Teledyne with was help us build a system where we could detect that real time and allow the operator to step back and clean that area up while the dredge was still on location. Or in an aggregate deposit, get that material before we put tailings on top of it. The image on the left is a very similar image to the one that Ted had shown just a minute ago, and it is a post survey from a dredging site. The humps you see are material that was left behind. Some of the lower areas is material that was dug that really the aggregate producer didn't want. So that typically would have been clay material that now they had to process. The goal of this system is to get rid of these things. Next slide, please. So after meeting with Teledyne and Trimble, we came up with a suite of products that we wanted to try in the field to see what we could and couldn't do. The first thing we had to do was select a dredge. We had a brand new 8-inch Moray dredge, which is shown on the left. That's a very small swinging ladder dredge. And we had to find a location. Well, it just so happens we have a wastewater pond in Louisiana by the DSC facility. Unfortunately, it's very shallow and very dirty. It's full of debris, sticks, even alligators. So I couldn't think of a worse condition to try this in. And we outfitted this dredge with several different sonars, with an RTK Trimble system, with the DSC RX or the Dredge RX package. We put the dredge in the pond and wanted to see if we could actually see the bottom and if we could see what the dredge was doing. The image to the right is some of the sonar returns we got back off of the imaging sonar. These images are not what we wanted as far as bathymetric to look at the bottom, but in this pitch black water, you can actually see the cutter head spinning and the ladder moving, and the ridge you see up at the top is the bank in front of the dredge. So we were able to see real time what the dredge is encountering. The next important thing with this is, as we saw this, could we take the image data and turn it into something that we could do bathymetry with? or show a record or map the bottom. And we were able to do that. So this was just to prove the concept. Next slide, please. The next step was to put this in place on a real dredge. And there was no better tool than the newest dredge DSC had created, our SHARKUDA. What you see now on the same animation you saw earlier, we didn't know where to place the sonar originally. You see the sonar sweep now taking place on the SHARKUDA. That's that bluish looking cone. So the dredge is not only seeing the cutter head position as it moves across, but it's seeing the area in front of the dredge and the area behind. So we moved this dredge into the Red River. The Red River is located between Texas and Oklahoma. This was some of the DSC team that put the dredge together, and it was outfitted with a non-RTK Trimble system and an imaging sonar from Teledyne with the Dredge RX package and automation tied into the dredge control system. So you're seeing the dredge actually operate now, sped up slightly in a video. The sonar is located on those forward tanks that are moving ahead of the dredge, and the sonar is sweeping from left to right. We also had, once the dredge got in place, we had the CARAS team join us, and that was the photo there. We had the PDS team join us, and we had the Trimble team join us remote. And we spent a week tweaking sensors, aiming sonars, and collecting data as a final proof of concept, and going through all the things that we might need to change before we roll this package out. Next slide, please. One of the things that jumped out right away on the SHARKUDA product is the equipment that we had on there was bulky, and the equipment that we had on the dredge really required somebody that knew something about surveying to use. And that wasn't the goal of DSC Vision. So CARAS was tasked with making this simple. The image at the lower left is actually from our Moray test, and you can see how small the cab is. The dredge is very simple to operate. It operates with just a few buttons and a single touch screen. The software, on the other hand, was very, very complicated. Just to set up sensors on the ladder would take hours. The end result, after we worked with CARAS, was a package that pretty much was a button click type software. So what you see now on the right is what the software looks like when the operator first turns the dredge on. And depending on what dredge and what fleet of dredges they have, the operator can select which dredge he has. And in some cases, we have dredges that have different attachments. So long ladders, short ladders, tilting ladders. So the operator would simply do a single click on the dredge type that he had, and then a single click on the project that's set up, and basically a start button. So there's no more aiming sonars, setting sensors, building models of the dredge. That's all pretty much done now and built in a simplified way for us to operate. Next slide, please. So now we're ready to roll out DSC Vision. And DSC Vision's has to encapsulate a lot of different industries and dredge types. So this graphic was really designed to illustrate that. If we start in the upper left-hand column, right below the factory, we have a DSC Barracuda dredge, which is a swinging ladder dredge in a lake management job. And you can see the sonar cone in the bottom being positioned underneath that. Typically, the lake management jobs are shallow. Depending on whether it's a governmental agency or not, it may require very, very high levels of precision and high levels of bathymetry. Or if it's privately held, they just want it cleaned up. So it really varies. And usually, those applications are not very rugged. They don't require very robust equipment. The next image to the right is our Moray dredge in an environmental cleanup operation. That dredge is actually pumping into a set of geobags. The level of precision on environmental jobs and the level of reporting is the highest out of anything that we deal with. It's very expensive to process contaminated material, so it's very important that the dredge gets it all the first time and doesn't get anything that's not contaminated. So it has the highest sonar requirements, the highest GPS or GNSS requirements, and the highest dredge control and reporting facilities. As we move to the upper right corner, this represents an aggregate pit, sand and gravel. The dredge that's actually shown here is our DSC Marlin dredge, which is our mining dredge. It typically operates on 3 wires, 2 swing wires and a stern wire. Its positioning and control is very, very simple. The level of accuracy is usually not very accurate. In an aggregate deposit, if you can get within a foot, usually everybody's pretty happy. In the environmental industry, they want to be less than an inch. What is very complicated on the aggregate market is the depths that we operate at and the severe duty that these machines see. They have cave-ins, they have run up against boulders, so the equipment has to be very, very rugged. Directly below that, depicted, is a SHARKUDA dredge operating in an aggregate deposit in the river. Again, depending on the governmental agency, this may require heavy reporting or it may not, but it's certainly the movement of the SHARKUDA dredge is the most complex and requires a very high precision GNSS system and dredge control system. As we move back to the left at the bottom center of the screen, we're showing a shark or a conventional CSD doing navigational dredging in a channel. Navigational dredging is typically controlled by the Corps of Engineers and requires very high levels of precision and very good levels of reporting. The equipment can also be subjected to quite a bit of impact, and we're in usually at salty conditions or often salty conditions, so there's corrosion that has to be taken into account as well. And then to the left, the lower left image depicted is basically a recreational lake type cleanup. And what's shown there is our Wolverine dredge that comes out of our Michigan facility. Typically, those jobs are they have the least requirements for precision and the least requirements for reporting. Basically, they just want to know that it's safe for boaters. So the system in that case would basically have to just do some general reporting. And actually, that Wolverine dredge is the least automated machine we have. So it then would have to work with a machine that has no automation on it. So what we've done with the DSC Vision package is we've come up with a package that works for all of these things. It's much more than an affordable sonar with a positioning system and connectivity. It's an engineered validation tool connected into the dredge control system that's designed basically differently for every one of these applications. And it's designed to assist the operator and to inform management at the same time. Next slide, please. And this is the culmination of all the hard work that was put in by this team. These are actually the displays that the operator now sees when he's operating the dredge. And this one is on the SHARKUDA that is in Oklahoma. If you're familiar with normal a dredge package that tracks the cutter head, you'll notice on those packages that basically a line tracks where the cutter head moves. If you notice in this image, once the dredge started swinging, it's basically profiling the pond. And in fact, in some cases, even with the ladder above the water, it can profile a whole pond where you never had a survey before. So it's not only picking up the cutter head position, but it's picking up what's behind it and what's in front of it. There's a variety of views that are available to the operator, pretty much at just a click. The isometric views, plan views, front views, but all fairly simplistic. The image right now on the left is the sonar return, the leftmost portion, and that's that green orangish looking line. And that's where the Teledyne software basically detects what the bottom is. But what's important about that image is you can also determine to some extent what the material is that's currently being encountered. On the Oklahoma dredge, we were able to tell the difference between sand, shell, gravel, and debris. So as this package unfolds, a permanent map is created as to what the dredge has done. And even if there was no survey before, the dredge is creating a real-time survey as it digs. So Christina, at that point, I think I'm going to open this up for questions and comments.
Excellent. Thank you very much, Bill. Very informative. We do have a little bit of time for some questions, and we have a few that have been submitted. As a reminder to anyone on this webinar, if you have any questions that you have not yet submitted, please go ahead and do that in the Q&A or chat box section. We'll try to get through as many questions as time allows. It looks like the questions I have, Bill, are probably more for you at this point. The first one is, can you talk a little bit about the cost of DSC Vision, or really more specifically, the expected return on investment of the DSC Vision product?
Okay, that's a loaded question, depending on which of those dredges we're talking about. But if we take a subset of that, and for a minute, let's speak about the aggregate market, the sand and gravel market. If a foot of material over a 5-acre pond was left, so that would be 1/4 of a meter of material over a 2-hectare pond, you've more than justified the cost of the DSC Vision system already. So on an aggregate type market, just on the sonar positioning piece, if you don't have a rate of return of a year, there's something wrong. And if you take the dredge RX portion in and you have any single problem on the dredge, the rate of return is almost instant. Our goal in this package is actually for this system to actually leverage part of the cost of the dredge, not just of the equipment itself. When we get into environmental issues and issues like for Corps of Engineers, it's very, very expensive to relocate a dredge back on location when it failed a survey. All it takes is one of those and the equipment has already recovered its full value. So in a nutshell, that's pretty much how to respond on the rate of return. The cost will vary depending on which of those dredges and which of those applications are required. There's different sensors required for swinging ladder dredges, and there's some different sonar options depending on the level and on the GNSS system, depending on the level of precision. On an individual basis, we can quote that to anybody who would like to know.
Excellent. Thank you, Bill. And we will provide an opportunity at the end of this event for everyone to express an interest in having someone follow up with them if they're interested in that. Let's see, the second question we have is, can you speak to the life expectancy and the warranty of this product and how that's handled? Sure.
The warranty on the product is a standard 1 year after installation warranty, just like it would be on a DSC dredge. Obviously, the warranty is not going to be valid if it's abused. So if we drop a dredge pump shell on it and bust the sonar, that's not going to be covered under a warranty. But any normal type of use, dredging use is. The equipment is very ruggedized. The Trimble equipment is marine equipment. It's very robust. So is the load right equipment. And the Teledyne equipment is very, very robust. Probably the least robust system on the whole thing is the computers that are actually processing the data. Most of the computers people work with now have at least a 5-year life expectancy. I would expect that the computer end would have at least that, and the rest of the equipment much longer than that. DSC, because this equipment is fairly technical and can be fairly expensive, DSC is acquiring hot swap equipment. So basically, if there was some type of a failure on any of the equipment, within 24 hours, DSC would be able to offer a replacement on site. If it's a software type issue or something like that, the Dredge RX system allows us instant access in, where we can actually guide the operator through whatever problems he has, whether it's on the equipment or something technical on setting up a project. I hope that answers.
Wonderful. Thank you, Bill. Yes, very much so. Yes, that did. Thank you. Let's see, I think we probably have time for another question. Can the data acquired from DSC Vision be used on other surveying and civil engineering estimating packages?
Yeah, I'll take the first stab at this, and then I may turn this over to Ted if he wants it. The engine behind all of this that the package started with was the PDS software from Teledyne. Now, this is a smaller subset of that specific for DSC, but because of that, there's tremendous surveying and mapping tools built in, and the database that's built is transferable into other civil engineering packages or from other civil engineering packages. And Ted, I don't know if you want to touch on that at all or not.
I think, thank you, Bill. I think that that's a very valid point. But again, if you recall during the presentation, we talked about we have the pieces, okay, and bringing our two phenomenal software packages together with PDS and Keras. We took a very robust piece of software that is used in applications from survey to bridge and dam inspections to actual construction applications, from a wire crane to a dredge, et cetera. So yeah, the package itself has been trimmed down again for the operator to have vision. But again, as different applications come up or different uses come up, the technology is an extension of the core package, which will allow you to do so. So you're very set up to grow with the system, either backward or forward. And what I mean by that is a new dredge comes out off the line, like Jonathan White mentioned, it's OEM ready. However, existing fleets of dredges out there can be equipped as well, because the technology is backward compatible. And then, of course, the different applications from inspection to survey to real-time marine construction are all available. Thank you.
I think that was a good answer, Ted. And I'd like to add on to that. If this package is added onto an existing piece of equipment, the more this package can be tied into the operational control of that machine, the better the results get. So the less it's just a standalone package and more integrated into the dredge, the more efficient this system is.
Excellent. Thank you both. I think that's probably all the questions we're able to take today. Thank you to everyone who joined us for today's webinar. Bill, Ted, Jonathan, thank you very much for sharing your insight and expertise with all of us. If anyone on this call has any additional questions or would like to connect directly with the DSC Vision team, you can either reach out directly through the website provided there on the slide in front of you. We also have a poll that should be going up momentarily that will invite you to indicate your interest in receiving additional information after today's event ends. Please take a moment to fill that in before you log off. Thank you for your time, and we hope that all of you have a wonderful rest of your day. Goodbye, everybody.